Hey everyone, this is a problem that where they want you to use the product rule. So they're going to say find y prime by applying the product rule and multiplying the factors to produce a sum of simpler terms. So this is kind of it's a little bit of a long problem. Let's go ahead and look at what the function looks like. So this function is y equals 3 minus x squared, x cubed, minus x plus 1. Now if you notice, there's a multiplication between the two parts of our function here. So this is why we have to use the product rule. So let's look at what the product rule is. So if we look down here, the product rule of one function times another function is equal to the derivative of the first function times the original function of the second one plus the original function of the first one times the derivative of the second one. So long story short, you take the derivative of the first one, take it times just the regular second function, and you add the regular first function with the derivative of the second function. So let's go ahead and show this. So if I want to find let's find the derivative of the first function first. So let's write all this out. We're going to say that we know f of x times g of x is going to equal f prime of x times g of x plus f of x times g prime of x, which in our case is going to equal, I'm going to take the derivative of this first function. So I want to say f prime of 3 minus x squared times g of x, which is just this regular function, which is x cubed minus x plus 1, plus this other function, which is the original function of x, f of x, which is 3 minus x squared, and that's going to be times the derivative of the second function. So I'm going to say g prime of x cubed minus x plus 1. So let's go ahead and find the derivatives then of this term and this term. So I know the derivative of this term. Remember, when you take the derivative of a constant, that becomes 0. So this cancels out. I bring the 2 to the front, so I end up with just 0 minus 2x times x cubed minus x plus 1 plus 3 minus x squared. When I take the derivative of this over here, I end up with 3x squared, right? The 3 comes to the front, so I get 3x squared. The derivative of negative x is just negative 1, and then the derivative of 1 is 0, so I end up with plus 0. So I end up with negative 2x being multiplied times x cubed minus x plus 1 plus 3 minus x squared times 3x squared minus 1. And this is the derivative using the product rule of this first function here. Now you could obviously simplify this out by distributing this through and doing other things like that, but we don't actually have to do this for this first problem. We can just kind of leave it like this. The second part of the problem now, they're going to ask us to find the derivative, but they want us to multiply the factors to produce a sum of simpler terms. So they want us to take the original expression, So take this original expression and multiply it out. So I'm going to write this down, this original function here. Let's kind of write this, we'll write that right here. Negative 2x times x cubed minus x plus 1 plus 3 minus x squared times 3x squared minus 1. Now you might not have this complete in the video. I'll kind of show you, it's off to the side here. But I will pull that back later on and we'll use that. So let's kind of erase, I'm going to erase this and let's go to part B. So part B, it wants us to take the original function, which is here, and it wants us to multiply it out. So 3 minus x squared, x cubed minus x plus 1. So I'm going to take 3 times the x cubed. Remember, I'm going to distribute this to each term. So the 3 to each term. So that's 3x cubed minus 3x, right? 3 times negative x. And then plus 3 times 1, which it gave me the 3. Now I'm going to go with this other one, and it says negative x squared times x cubed is negative x to the 5th. Negative x squared times negative x is positive x cubed. And then negative x squared times 1 is negative x squared. Let's combine like terms and put them in a better order. So we're going to call this negative x to the 5th. Let's see, 3x cubed, and x cubed gives you 4x cubed. Right, if we combine this one and this one. And then we have negative x squared minus 3x plus 3. So this, for part B, this is what they're going to ask you to do in your problems. And that's all they wanted to start with. Now they're going to say, find y prime. So they want you to find y prime for this. So what does that mean? They want you to take the derivative of y with respect to x of this function. So that's negative x to the 5th plus 4x cubed. I shouldn't have put in parentheses. Plus 4x cubed minus x squared minus 3x plus 3. So let's take the derivative of that. Now I could write this out. Remember, this is just a sum and difference rules. I could write this out like I did in the previous videos. I'm not going to do that now because eventually that just becomes a little too much writing. So I'm just going to actually find the derivative of each term separately because I know I can do that. So I'm going to say that dy over dx equals, when I take the derivative of this first term, the 5 comes to the front, so it's negative 5x to the 4th, right? We go down by 1. The second derivative, or the derivative for this term, is going to be positive 12, 3 times 4, right? X to the, we go down by 1 squared. Derivative of this term is going to be minus 2x, right? 2 comes front, we'll go down by 1. Negative 3x is just going to be minus 3. And the derivative of 3 is 0. So I don't even have to write that. So this derivative here is negative 5x to the 4th plus 12x squared minus 2x minus 3. Now my assumption, I believe, if we took the derivative up here, we're using the product rule, they want us to check to make sure that we ended up with the same thing. So what I'm going to do is I'm going to now, let's write this. Well, we have this function here. Let's go ahead and kind of bring this back. I can slide over a little bit. Let's multiply and distribute in here, and let's distribute this out. And let's see, do we end up with this same thing? So negative 2x times x cubed is going to be negative 2x to the 4th. Negative 2x times x, or negative x, is positive 2x squared. Negative 2x times 1 is negative 2x. And then we end up with let's multiply this out. So we're going to have plus whatever happens on this side. So I'm just going to kind of put this in parentheses here. 3 times 3x squared is 9x squared. 3 times negative 1 is negative 3. Negative x squared times 3x to the fourth is negative 3x to the fourth. And then finally, negative x squared times negative 1 is going to be positive x squared. So remember, we did the product rule to get this answer up here, and we didn't like distribute it out. So I'm going to, that's what I'm doing, is I'm distributing this out, and I want to see, does this actually equal this? Because they should equal each other. So that from there, I can now get rid of these parentheses. So I'm just going to have negative 2x to the fourth plus 2x squared minus 2x plus 9x squared minus 3 minus 3x to the fourth plus x squared. And I need to start combining like terms. Let's start with the highest terms we have. Negative 2x to the fourth, negative 3x to the fourth. That gives you negative 5x to the fourth. Notice we got the same term in each. Okay, I'm going to slide this up just a little bit. We've got the same term here as we have here. Okay, negative 5x to the fourth. And that was combining this together with this. So then let's combine the squared terms. So we get 2x squared with 9x squared with x squared. That's 10x squared, 12x squared. Notice, exact same. And then let's find negative 2x. Oh, that's the only one. This is the only term, so we're going to write this down here, negative 2x. And then the only other term we've got is negative 3. Look what we got. So using the product rule, this is kind of a proof here. So using the product rule, we ended up with this for our derivative after we distribute that out. We end up with this. When we distribute this function out first, right, we distribute that first in part B, and then found the derivative, we got the exact same derivative. So that's kind of a proof of what the product rule does.